Okay, here we go with a question, very common question with graphs, we've got acceleration time graphs here. I've noticed this a lot in IB questions recently. Okay, we know the variation of time t of the acceleration and we want to know the average force. Take a second to try the question and then watch on for my explanation. All right, so average force, we're going to start off by thinking about our graph. Now we've got an acceleration time graph. Okay, it's really instructive to have our Newton's second law in our brains here. We've got force is equal to the rate of change of momentum. In other words, m delta v over delta t. Okay, why is that important? Well, the area under the graph gives us the change in v. Okay, in this case, you've got a changing acceleration. So you're going to have a changing force. We want to turn that changing acceleration and changing force into an average. And to do that, first we need to know the change in the speed, or the speed of the change of velocity. So we've got a 1 times 6 here, and we've got a 4 on the base times a 3 here. So we're adding together a rectangle and a triangle. So we've got 1 times 6 plus half of 4 times 3, which gives me a change of speed of 12 meters per second. Now, to do this next bit, we're going to remember, well, delta v over delta t is going to be our change in speed, 12 over 6, yeah, that's the time, times 3, which is the mass, which gives you 6 newtons, which is why the answer here is 6. And like I say, this is a good combination of a non-constant thing, right? We've got a changing force becoming an average constant one. I hope you've understood the analysis here. This, as I say, this area is really important. I've noticed it's coming up a lot now. Change in speed is the area under here.